Hello everyone. In this video I want to show you how to fetch OpenStreetMap's data and show it in your and get it in your Grasshopper. So basically it will allow us to download any surrounding data for your projects like buildings and streets and parks and forests and whatever you want. Yeah, let's just start. So first of all, we need to go to the openstreetmap.org website. This is the official website of OpenStreetMap. You can search for location here, like Erfurt, and here I am in Erfurt. And then you can zoom in, you can pan the map until you find the right spot which you want to export. And then you simply need to find this export button at the top. And you see that there is a new window, a new panel now on the left. And as you move your map, as you zoom it, you can see that the coordinates of this export area also change. So it basically means that whatever area you see now on your screen will be exported to the file on your local device. So I will just zoom in a bit in the Erfurt Altstadt, click export, and the download of a new file should start immediately. So here in my downloads, I see map.openstreetmaps. It should probably take you seconds to download this map. It's really quick. Sometimes if your map area is too huge, like if you want to download the full Erfurt map, sometimes this button will be inactive. Or sometimes you will get an error that you cannot export this area of the map. In this case, you can simply use the first link which you see here, which is called Overpass API. This is basically another technology which allows you, another method which allows you to download bigger maps. It doesn't matter that much what the difference between these two methods is. The key is that it allows you to download bigger files like this one, which is 10 times larger than the previous map. Yeah, okay, now I can close my OpenStreetMaps data, and I can start showing you how to do it, how to connect this file in Grasshopper. So the full process is quite simple. I will go a bit more in the detail now to show you also how to extrude buildings in their correct 3D shape. But basically, let me start with a new file. And the first thing you want to do is to go in the Tools, Options, open Units here, and check that your units are set to meters. This is quite important because my Rhino was set to millimeters, and so I have just spent half an hour trying to understand why everything is so slow. So it just happens that if your model is set to millimeters, then all operations are taken a bit longer because Grasshopper needs to compute more because it works with much bigger numbers than if you would have it in meters, right? So please set it to meters, click OK, and you just need to do it once. And then if you know that your Rhino is opened in meters mode, then you don't need to change it every time. Now we need to have one plugin, which is called Caribou, to work with OpenStreetMap data. To download it, you can navigate to the Tools toolbar of your Rhino and open Package Manager. In the Package Manager, you might need to wait a while until it loads all the plugins. And you need to enter Caribou here. Yes, you should find this plugin. You can check that you have the latest version selected here and click install. You only need to do it once. So as soon as you have installed this plugin once, it should always be available in your Grasshopper. You'll probably see this banner that you need to restart Rhino now to actually see this, see and use this plugin in Grasshopper. So please do it. I have the plugin installed, so I don't have to do anything. And now after you have restarted your Rhino, you can find this plugin on the top panel by searching for Caribou or simply C, like in my case. And here you will find those components: extract buildings, extract nodes, extract ways, and filter text, specify features. That's basically it. I will need to start with extract ways component. And ways does not necessarily mean streets. It also can be buildings or country boundaries or anything which you can describe by a sequence of points. So by a polygon or polyline or a line. If you need to extract points, you can use extract nodes component. Extract buildings also works to extract buildings, but I will show you a bit different way because this is how you can get more accurate data. I don't know why this extract buildings does not work. Maybe it will work later in the in the next versions of this plugin. I don't know. Now somehow need to reference our OpenStreetMap file here, and to do this, I will use the file path component. So I paste it on my canvas, right-click it, select one existing file. And I will select the file which I already downloaded before, which is called effort.openstreetmaps. Now I can simply connect it to extract ways. And now the second input of this extract ways component is called OSM features. And you can actually simply create a panel and type highway here. And as soon as you connect this panel to OSM features, you will immediately see how all your streets of the map are actually already referenced in Rhino. And this is quite cool. This is why I really like this plugin. It just lets you start very quickly, but also it allows you to filter the streets or any features which you want to show on your, which you want to have on your Grasshopper canvas. To do this, you will need to use specify features component. So it basically, as you can see, it has OF, OSM features, output, and one of the inputs of extract ways is also OF. So it can already give you a sign that you should somehow connect them. Right, so specify features works with extract ways in a very good way. Now you can see this button here, specify features, and if you double click it, you will see this really nice and neatly structured list of all feature types, which you can see in OpenStreetMaps. And so I'm interested in highways currently, so I can either select the full category, or instead I can expand this category and select only some of the subcategories. I'm looking for primary streets, secondary streets, tertiary streets, and I think sometimes you would need to try out selecting or deselecting different subcategories. I prefer to use residential. I think pedestrian was also quite important in Erfurt because many streets are pedestrian. I think something like Living Street. Yes, Living Street here. So I will select those things, press OK, and you see that in a matter of seconds, I got my streets updated, and now it looks a bit more correct than what I got after I connected the highway panel there. So here you can see all different types of streets, but normally you would just need the most major streets. So yeah, I usually use this living street, pedestrian, primary, residential, secondary, tertiary tags. Okay, so it's basically it for the streets. And now I can copy this component, extract ways, and also specify features. And now I want to go into this second specify features, deselect my highways completely, and select buildings. Let me select buildings, and here we go. So quite simple, right? This is how you can get all buildings available on OpenStreetMaps, which are inside the boundary you have just selected on your OpenStreetMap website. That's nice. And you can already start working with it. So the W output here accounts for ways. So in this case, these are the buildings stored as polylines. I can also work with my streets now. So that's all fine. What I wanted to show you is how to extrude buildings in the correct height now, because currently buildings only have, this is only 2D geometry. They do not have any height. These are simple polylines. What if I want to extrude them? So to extrude them, I would need extrude component, where I need to connect my buildings. And as the direction, I would need my Z vector. And I need to give it some factor. So I need to specify the height of the buildings. And of course, I don't want to do it manually, or yeah, I want to get this information from OpenStreetMaps itself. And also you see now all the buildings are simply extruded by the height of 1 meter, but we don't see the roofs here. So I want to cover my buildings with flat roofs for now, and I don't see them. This is basically because I use polylines instead of surfaces to extrude them. So one thing I could do is to convert my polylines into surfaces and extrude surfaces. And I think it is actually the preferred way, which I will choose. Okay, so the problem now is to get those heights of buildings. This is not quite so obvious how to do it, but I will show you the way. So extract ways has 4 outputs: so ways, tags, report, and bounds. We are interested in the second output, which is called tags. Let me check what is stored there. So I have my tags. Let me connect it to a panel because it is a text information, and let us see. In this panel, you can see which kind of data is stored inside and which structure is used for it. So for 3,840 buildings, which I have here, I have 17,000 something tags. So the number of tags does not correspond to the number of buildings. But what you see here is that number of branches correspond to the number of buildings there. So I have 3,839 branches if you start counting from 0, so 3,840 in total. And I also have the same number of branches and the same number of objects in the building's output. So it basically indicates that each building has multiple tags, right? So this one branch, so branch number 00, contains all tags for the building inside the branch 00. So this building, what do we know about it? We know that the type of the building is church. We even know that its architectural style is Gothic. It is a heritage building. It has some name, so it is historic, and so on. So many buildings in OpenStreetMaps will actually have some information connected to them. We are interested in information like height equals 20. And actually height equal 20 means that the building height is 20, but most of the buildings will have this data stored a bit differently. Let me try to find it here in the next entries. Yes, like here. Building levels equals 2. This is what you would normally see in like 70% of all cases. Building height will be stored as levels, as number of stories, and not as the total height. And so this is what we will look for in this tags. Let us try to filter those tags. So let us try to find tags by their keys And yeah, one small note, if you're talking about keys and values or tags, key is the name of the tag. So everything which comes before the equal sign and after the equal sign, we have the value. So the tag address city equals to the value Erfurt. Yeah, so now we need to get all keys, all values, and find the key height or building, where was it? Building levels, and we want to fetch value of this key. So the value of this key is 2. We want to get this. We can do it in Grasshopper. So first of all, we need to break this information, this text into keys and values. I can use split. I can use text split component for it. So it receives the text, my text, and the second input is separator. In my case, separator is the equal sign. So I create a new panel with an equal sign, and as I connect it to the text split, you will see that now all my tags are split in 2 parts: tag and the key, tag and the key, and so on. So the country, Deutschland, postcode 99084, street, Kleine Arscha, and so on. Now I want to use this key value search. I believe this is the built-in component which takes the list of keys, the list of corresponding values, one value per one key, and it can search for keys. So you can say, okay, here are the keys of my building. Here are the values. I want to get the value for key building levels. Right. So this is what I want to do. For this, I need to convert my data a bit, because now my data is stored in separate branches, and each branch has key as the first element, and as the second element, we have the value of this key. We want instead to have 2 lists. First list will contain all keys, and the second will contain all values for these corresponding keys. I can do it with dispatch command or dispatch component, which receives a list, and as the output, and you can also specify the pattern of the output. So true false will mean that the first element of the key goes in the A output, and false means that the second element will go in the B output. So if you would have more elements, you can specify like true, false, false, true. And it will mean that the first element will go in the A, second will go in the B, third in the B, and fourth in the A again. So true means A, false means B. And the same pattern will be applied for all branches, of course. So when I check the output of A, I will see those individual branches containing city, country, postcode, street, and so on. So names of my tags, keys of my tags. And the second output B will contain the values of them: Erfurt, Deutschland, 99084, and so on. Now I want to get rid of those last branches. I don't want these keys and values to be stored in individual branches. I want them to be stored, like all tags should be in one list per one building. And to do this, I can use the trim tree component, which basically gets rid of this last branch indices. Let me show how to do it. So you simply connect the A output to the trim tree, and you will see this nice list of all keys for the first building, all keys for the second building, and so on. I, of course, need to do the same for the values. Yeah, you can also compare what you have in those two lists. So these are my keys on the left and my values on the right. So city Erfurt, country Deutschland, and so on. Nice. This is exactly the type of information I need for my key value search. Let me also name it. So these are my keys, and these are my values. I can now connect them to the key value search component like this. And the third input is search, a key value to search for. I want to search for, I think it was called building levels. Let's try this one. The component glows red, probably because some of the keys did not have corresponding values. So the error goes like, you must supply equal numbers of keys and values. Hopefully it won't do any bad to my data. So probably some of the buildings will just lack information about their height, but I hope it doesn't spoil the whole data. It looks quite good, quite promising. So many buildings do not have this data, but most of them do. And this is already something. Now, and yeah, let me check the output. So the output is now 1, 2, 5, 4, and so on. These are not heights of buildings in meters, but instead these are heights of building in stories. So it's 5 stories, 4 stories, 5 stories, and so on. To get information about heights in meters, I of course need to manually estimate the height of stories and multiply number of stories by this value. So let's just use maybe 3, or you can use 3.2 or whatever to get the actual building height. Right, I can also name it somehow, building height. And now I can finally connect it to my unit Z input. So this operation of extrusion might take a while, probably because, yeah, Grasshopper needs to extrude a lot of individual buildings. But yeah, after a couple of seconds, you see that my extrusion is already finished, and it indeed looks pretty good. So many buildings have their height, and it looks very accurate, actually. Of course, many buildings will not have any information about the height, so they will probably be extruded to 1 meter or maybe to 0. I'm not so quite sure about it. Okay, so I would say we're finished with buildings. We're also happy about our streets. Let me maybe add final touch to it and show you how to filter this data based on some areas. So imagine that you want to build something in this region, and you need your surrounding buildings and surrounding streets to be around, but you don't want to see this geometry inside the boundary of your site. So let me also draw a site. I will just use the polyline tool in Rhino, and yeah, I will just draw something like this. Oh yeah, maybe like this then. And close. So this is the closed polyline, which accounts for the boundary of my site. And I want to get rid of all data inside it. First of all, I need to reference this curve. Yes, so I create a new curve. I name it boundary. And let me use set1curve to reference it. Okay, so it glows green. That's fine. It means that it is referenced correctly. Now, how do I filter out all streets which are inside this boundary? For this, I can use the trim with region component, which allows me to take any curves, so polylines in our case, and any region. And my region is the boundary. As the output, you will see 2 outputs, inside as the list and outside as the list. Let us check what the first input has. And as you can see, it has all the streets which happen to be inside our boundary. And accordingly, the second input, the second output will have all streets outside our boundary. Right. So if you want to filter out some streets, you can now just change the perimeter of this boundary, and you will get rid of streets inside it. That's quite nice. The same applies for buildings, of course. So if you are simply working with 2D buildings, like these buildings, you can filter them out in the same way. So you can, let me check. Yeah, I can copy this component, trim with region, and connect my buildings into the curves input, right? And in the second output, outside, I will get all buildings which happen to be outside of my boundary. And as I change the boundary, the buildings also automatically update. And yeah, you don't see buildings which are inside the boundary. Let me turn it all back. I actually haven't ever tried to do the same with 3D buildings, but I'm sure we can find a way to do it. So let me actually just try to do the same operation. Yeah, let me just try to use the same trim with region and take its output of buildings and connect it to the surfaces, which connects to the extrude. Again, it might take a while, and let's see what the result will bring. Okay, I think it looks pretty nice. So you can see that my surface component now glows red. It indicates that not all polylines were successfully converted to surfaces. It might happen from the fact that not all polylines are closed. But if you just check the outputs and if you will not notice any peculiarities, and if it will all look pretty fine, it probably means that the data is also not corrupt and you can indeed use these outputs. So in my case, I can see that those modernistic Plattenbau buildings are pretty high, and all city center buildings are low, but they all have different height. In the best case, you can also compare some reference buildings from the map, which you know the height of, and then after you have ensured that the geometry is looking fine, you can just use those buildings now. So these are my buildings 3D. Okay, this is it. I hope you enjoyed this video, and yeah, see you in other videos.